Hello again. If it's all right, I'm going to talk about some more about science again, if that's all right. Thank you for that. Thank you very much. Um, yeah, so I just like to say that Alexander Fleming was the discovered penicillin. So the discovery is attributed to Alexander Fleming, and the development of penicillin for use as a medicine is attributed to the Australian Nobel laureate Howard Walter Howard Walter Florey. So he sort of improved on Alexander Fleming's work. So Alexander, if you like, pioneered. He discovered it by accident, penicillin, and as we know, Alexander Fleming didn't know how to produce enough of it to be effective. But Howard Florey developed penicillin so it could be the yield was stronger, and he could it could be used effectively, and the dosage was higher, or something like that. So I just wanted to say that to you. And the if I mention this word flagella, and the plural, the singular, I think is flagellum, is a long hair-like structure that rotates to make the bacterium move. But not all bacteria have one, apparently. So that's what it says here. So I just thought I'd tell you that. Just wanted to say that to you. And also, while we're on the subject of penicillin, I just wanted to say that the eight white mice were given a lethal dose of virulent streptococci bacteria. Four of them were injected with penicillin. So so the four that were untreated, that didn't have the penicillin, and were just given a lethal dose of virulent streptococci bacteria, and they didn't have the remedy, which was penicillin, died, and the other four survived. So they sort of knew they were making progress with Alexander Fleming's work, and they were improving on his ideas, if you like. And also so I just wanted to say that to you. And antibiotics diffuse into the agar, and kill the bacteria. That's also what I wanted to say to you. Penicillin, a molecule used as an antibiotic which kills the growth of certain kinds of bacteria. So I just wanted to say that to you, if you don't mind. What else? And also, if I mention vaccines, and I think Edward Jenner pioneered vaccines, didn't he, back in the early 18th century, something like that. And so I just wanted to say that. So something attenuated. It's something. It's to do with reducing the virulence of a pathogen, but still keeping it alive. So attenuated takes in the infection agent and alters it. So yeah, it takes the infection agent and alters it. So it becomes harmless, less virulent, if you like, but still keeping it live. So and then I think it's something to do with the antibodies kick in, or something like that. The phagocytes and the lymphocytes come into their own, and then you've got that's right. That's all I want. That's what I wanted to say. The antigens it provokes, and then they attack the antigens, don't they? Something about that. The antibodies, the phagocytes and the lymphocytes successfully defeat the antigens. I think something like that. So I just wanted to say that to you. And thank you for listening to me. I just wanted to say that to you. Now, just wanted to say... Oh, yes. Viruses are microorganisms, but they're not cells. They're just nucleic acids surrounded by protein. They're tiny, even smaller than bacteria. Unlike bacteria, viruses have no plasma membrane, no cytoplasm, and no ribosomes. And the ribosome is in charge of the protein production, isn't it? I think. But the viruses, but they do have a nucleic acids. So I just wanted to, but they do have nucleic. So it's NucLeic acid. So I just wanted to say that to you. Anyway, so thank you for listening to me there. Thanks. And I just want to show you this now, actually. I want to show you this, if it's all right, if you don't mind. I've just got that there, and that's the fungus that defeats, the streptococcus and staphylococcus, those spherical bacteria-shaped ones, and they successfully, they defeat them, they destroy it. The penicillin, that one, nototatum, that one there. And I've also just written the molecular weight of ascorbic acid, which is 176. I just wanted you to see that, if that's all right. I just wanted you to see that. So yeah, it's 12 times 6 is 72, 1/8 is 8, and 6 times 16 is 96. And if you add 72, 8, and 96, it's estimated to be 176. I mean, it will be. Mine isn't quite precise. It's approximately. So if you go on your Wikipedias, you could find, but it's not. I just rounded it. I think I've rounded it down, actually. So I just wanted to say that to you. Now here, I've just written some other things now for you. You might be interested in this. I don't know. Anyway, I've got that there. And I've got the resistance equals OHMS, voltage equals volts, current equals amps. Current is equal in a triangle. If you do like the DST, you've got D at the top of the triangle, and then you've got S, and then you've got T. So if you want to find what the distance is, it's speed times times. If you want to find the time, it's distance over speed. And if you want to find the speed, it's distance over time. So I just thought I'd show. I just wanted to show you. You see that? Thanks. So yeah, current equals volts over resistance. Resistance equals volt over current. And voltage equals resistance times current. So I just wanted to show you that. Yeah. So that's R is resistance there. So yeah, and I got RESIS. So I'm just shortening some stuff here. Thank you for that. And I just want to write this down as well now. If I just show you this now. If I just show you this. Right, I just want to show you this here. So on this side, I've actually got this. And on this side, I've got this. Now, yeah, that's the resistance symbol there. My resistance symbol is a bit dodgy, but A for current and the voltage V. So I just wanted to show you that. Yeah, thank you for that. And so just wanted to show you that. Thank you for being patient with me. That's very nice of you. So I just wanted to show you that. Thank you for that. Right, I'm just going to talk about some other things now. See what else we can talk about tonight. I just wanted to say, another thing I wanted to talk about was that, as we know, neutral atoms. Sorry about this. Neutral atoms are like sort of insulators, and then they turn into conductors. It's becoming increasingly ionized. So the insulator doesn't conduct electricity, and then as a conductor, it becomes increasingly ionized. So I just wanted to say about sodium, for example. Now, sodium is 11 in neutral atoms. It's 11 electrons, 11 protons, and 12 neutrons. So it's an atomic. So its relative atomic mass is the ascorbic acid relative atomic mass was 176. So its relative atomic mass is 23 for sodium. So it's 11 electrons, 11 protons, and 12 neutrons. So it's 11 protons plus your 12 neutrons gives you 23 as the RAM, if you like, relative atomic mass, the weight. And so I just wanted to say that to you. Also, I wanted to say to you, the relative atomic mass for copper is 63.54. It's 63.54 for copper. And the isotope of cobalt is one of them is 60. So that means it's got 27 electrons and 27 protons and 33 neutrons. So this isn't the one on your periodic table. This is an isotope. This is an isotope of cobalt. So basically the same number of electrons and protons as the one on your periodic table, but a different amount of neutrons. So I just wanted to say that to you. And chlorine, I think. Chlorine's relative atomic mass is 35.5. I just wanted to say that to you. It's actually 35.5 for chlorine. Just wanted to say that to you. And yeah, I also wanted to say something else to you as well. I'll just rub this off here. Right. When I was talking about lead bromide, or and I wanted to write down the configuration for lead actually. Now, I'm talking about electrons here. I'm not talking about protons or neutrons, just electrons. So for lead, it is it's got 6 energy levels, and excuse me. Sorry about that. Sorry about that. Yeah, it's got 6 energy levels for lead, I think. 2, 8, 18, 32, 18 and 4. And bromide is 2, 8, 18 and 7. So it's 2, 8, 18 and 7. 2, 8, 18, sorry, my writing there. But so it's 2, 8, 18 and 7. Now, so that gives it the lead is 82. And as atoms go, lead 82 and bromine 35. Right? So that's what I wanted to say to you. Now, during the electrolysis period, I have mentioned this to you before, but I just wanted to say it to you again. It's the metals are oxidized, and I think the non-metals are reduced, aren't they? I think. Is that way around? Yeah. So, right. And then they revert back. So you've got your ions here, and at the end of the process, it goes back to its original element, if you like. So I just wanted to show that to you. Thank you for that. I just wanted to show that to you. So atom, ion, atom. So the metals at the end of they appear to lose the electrons and then they gain them, and then the non-metals gain them when they're ions, and then they revert back to atoms and they lose their electrons. So the non-metals lose their electrons at the end of the process, and the metals gain their electrons at the end of the process, but not when they're ions. So I just wanted to say that to you. Thanks for listening to me tonight. Just wanted to say that to you. Thank you for that. Just... Right. Right, I'd just like to... I would like to write out some chemistry stuff here, if you don't mind. Thank you for that. Right, I'm just going to write out this. That's ethanol, and that's the chemical compound, isn't it? There's the formula, should I say? That's the formula for that. Just wanted to say that to you. And if I write this out, that's niacin, I think. I've written out a niacin there. I just wanted to write that for you. Just thought you might be interested in that. So I just thought I'd write that out for you. Now, if I said to you, right, what is the percentage composition of carbon in carbon dioxide? Now, it's 27% actually, because what you do is you say. So again, the question is, what is the percentage composition of carbon in carbon dioxide, and it's 27%, and I'll tell you why it is. So here you've got carbon dioxide, and then it's 12, divide that by 44 times 100 over 1, and that is 27%. Just want to thank you for waiting tonight. Sorry about this. Thank you. I'll just get you this now. Right, so basically what you say is 12, divide that by 44 times 100 over 1. And it's 27.27%. So it's actually 27.27%. And the percent symbol is that, as we know. So it's 12 divided by 44. 12 divided by 44 times 100 over 1. So I just wanted to help you there. And another thing I'm going to do tonight with you is, right, I just want to write something else down for you here. Thank you for waiting patiently. Right, I just want to write this down for you. Right. Relative atomic mass, the RAM, if you like, of nitrogen equals 14. Relative atomic mass of hydrogen equals 1. And the relative atomic mass of oxygen equals 16. Right. Now, if I write down ammonium nitrate, I'll just write this down for you and then... And we want to find out what the percentage of nitrogen is. So what I do here percentage of nitrogen and right. I've just written this for you. So yeah, if I show you that there, and ammonium nitrate, so that's 1 atom of nitrogen, 4 atoms of hydrogen, 1 atom of nitrogen, 3 of oxygen. So it's 2 atoms of nitrogen, but this is the way it's written down. Anyway, so I just say 14 plus 4 times 1 plus 14, and then you've got 3 times 16, which is equals 80, because 16, relative atomic mass, is 16. And the percentage of nitrogen is 14 times 2, so that's 28 over 80. So 28. So basically, it's 28 divided by 80 times 100 over 1, I suppose. Is it? I'll just check. 28 divide that by 80 times. Yeah, so it's 28. It's 28 over 80. Over 80 times 100 over 1, which gives you 35%. Just thought. Yeah, so the percentage of nitrogen is 14 times 2 over 80, which is, or 28 divided by 80 times 100 over 1 is 35%. So I just thought I'd show you that. I've just written percentage of nitrogen, that's 14 times 2 over 80 times 100 over 1 equals 35%. Thank you for that. And then I'll just put that over there. 14 times 2 is 28. Thank you for listening to me. Thank you. Thank you for that. And another thing I want to talk to you about tonight is right, yeah, what is the relative formula mass? What is the relative formula mass of carbon monoxide? And that's 28. It's 28. And it's 12. Relative atomic mass of carbon is 12. And the relative atomic mass of oxygen is 16. Sorry about that, yeah. The relative atomic mass of carbon is 12, and the relative atomic mass of oxygen is 16. So 12 plus 16 gives you 28. So I just thought I'd say that to you. And then, of course, what is the percentage composition of carbon in carbon monoxide? So that's it's 43%, and it's actually 12. So what is the percentage composition of carbon in carbon monoxide? So that is, the answer is 43%. So carbon is 12 and oxygen is 16. So it's 12, just sorry for this. It's 12, carbon is 12 as we know, oxygen is 16, and it's 12, divide that by 28 times 100 over 1, I think. I'll just tell you if I'm right or not. Yeah, it's 40. Yeah, it's rounded up. It's rounded up to 43%. Right, it's rounded up to 43%. So it's. I just want to show you that one. So, what is the percentage composition of carbon in carbon monoxide? It's 43%. And I just want to show you that. There. Thank you for that. Thanks. Right. What else now? Yeah, another thing I wanted to say tonight was that that's right. I just wanted to say, hang on, yeah. So chlorine is a gas at room temperature. I just wanted to say that. Fluorine is a gas at room temperature. And nitrogen and oxygen are gases at room temperature. And iodine is a gas, but it's a It's a solid at room temperature. Iodine is actually a gas, but it's a solid at room temperature. So it would have to be heated up, wouldn't it? I think. I just wanted to say that to you. Yes. So iodine is a solid. It's a gas, but it's a solid at room temperature. Yeah. It's a strange one, that, isn't it? Just wanted to say that to you. Some other things I want to talk to you about now. Right, yeah, I wanted to say that I wanted to write up, I just want to write something out for you at the moment. I want to just say that if I write out MgCO3, that's magnesite, or magnesium carbonate. It's magnesium carbonate. So that's actually magnesite and magnesium carbonate are the same thing. They're the same thing. I think they are. But that's what I wanted to say to you. So thank you for that. Yeah. So magnesium carbonate, Mg. 1 atom of carbon, 3 of oxygen. It's magnesite or magnesium carbonate. Just thank you for that. I've just written that there. I know it's not okay. CaCO3 is calcium carbonate. That's calcium carbonate there. I just wanted to write that down for you. And in order to extract iron, you have to get it off hematite. Hematite, Hematite, that's Fe2O3. So I just wanted to say that to you. And iron pyrite is Fe. Sorry about this. FeS2. That's iron pyrite. So FeS2 is iron pyrite. Just thought I'd say that to you. FeS2 is iron pyrite. Iron and then P. Yeah, just fool's gold actually. Just wanted to say that to you. And dolomite is actually CaMgCO3 2. That's dolomite. So dolomite is actually is that one there. Just wanted to show. So that's that's calcium C, lowercase for the A, Mg. Ca, calcium, Mg, CO3, and then in brackets, that's CO3 is in brackets, and then it's 2. So I just wanted to show that to you. And that's dolomite. So it's Ca, calcium, so I just wanted to show that to you. And if I write magnetite down, it's an ore of iron, I think, and it's Fe3O4. So that's magnetite is an ore. So in order to extract iron, you've got to get it off the magnetite. Fe3O4. Just thought I'd show that to you. And calcium is CaMg, and then CO3 in brackets, and then 2 outside the bracket, and that's dolomite. Thank you for that. Thank you for... And nitrogen dioxide is 1 atom of nitrogen and 2 atoms of oxygen. So I just thought and nitrous oxide is N2O. So that's 2 atoms of nitrogen and 1 atom of oxygen. That's nitrous oxide. So I just thought I'd say that to you. And now I just want to write something else down. Very quick. So, calaverite. That's AuTe2. It's telluride. So in order to get gold, you have to extract it off AuTe2. That's what you have to do. And then you've got silvanite. And that's AuAgTe2. AuAgTe2. Te2. That's, and I think they're the ores of gold actually. Silvanite and calaverite. Just wanted to show you that. And then zinc carbonate is ZnCO3. So zinc carbonate is ZnCO3. Thank you for looking at that. And zinc oxide is ZnO. So that's zinc oxide. Thank you for that. And then you've got zinc blend here. And I think it's zinc. And then you've got cephaloryte. So it's SPHALE. So that's how it's spelled. That's SPHALE right. So I just wanted to write that down for you. And that is the, I think it's SNS actually. Just wanted to write that down for you. Thank you for your patience again. Right. Thank you for that. And then I've got ruby silver here. Ruby silver. It's Ag3, 3 atoms of silver, Sb, S3. So it's Ag3, Sb, that's 1 atom of Sb and 3 atoms of silver, of sulfur. Sorry about that, sulfur there. Just wanted to write that down for you. And then horn silver is AgCl. Horn silver is AgCl, so that's what I wanted to write that down to you for you. Cadmium is greenockite. In order to extract cadmium, I think you've got to get it off the greenockite. So it's green, and then green. You write as in green, and then OCKITE, and it's CDS. So it's one atom of cadmium and one atom of sulfur, I think. So I just thought I'd say that to you. What else can I say? Yeah, barium. So if you want to get barium sulfate, it's actually BARYTES. So it's BASO4. BASO4 there. Thank you for that. And then one more I'm going to do, and then I'll finish with you tonight now. Yeah, if I do one more, I'm going to do which one? Yeah, bauxite and corundum. Corundum is aluminium oxide, I think. I think it could be. And cryolite, I think that's an ore of aluminium, actually. Bauxite's an ore of aluminium. Corundum's an ore of aluminium. Aluminium oxide corundum, I think. A1203. And oh yeah, let me just think. Millerite is an ore of nickel. So I put, and it's actually NiS. So it's, I think, one atom of nickel and one atom of sulfur. It's millerite. So in order to get the nickel, you have to get it off the millerite. Millerite? Yeah, something. It's millerite, I think. Thank you for listening anyway. And if I just say, yeah, I just want to say one more thing, and then I'll wrap things up with you tonight. Yeah, so NiS is millerite. So in order to extract nickel, you've got to get it off the millerite or something like that. And let's see what else. And I think in order to get cobalt, in order to extract cobalt, you've got to get it off the smellite. I think it's COAS S2. I think, I'm not sure. I'm not sure about this. So, but I think it's that. And one more. Yeah, so copper, right. So, yeah, I want to just write. Yeah, I think copper cuprite is actually Cu2O, and copper glance is Cu2S. And then copper pyrite is actually CuFeS2. So I've just written it down there. CuFeS2. Yeah, and so copper cuprite is Cu, 2 atoms of copper, 1 of oxygen, I think. And copper glance is 2 atoms of copper and 1 atom of sulfur, I think. I think it is. Anyway, thank you for listening to me tonight. Go on. Thank you, and that's very nice of you to listen to me. Thank you. I'll just, if you like what I'm talking about, if you like what I'm talking about, could you subscribe to my channel? Is that all right? That'd be very kind of you. Thank you very much. Thank you. Bye.